So the next set of functional groups are called carbonyls. Okay, and that's pronounced carbonyl. Carbonyl. In case you missed it. So these are carbonyls, and all carbonyls contain a C double bond O. Okay? So we have this is a carbonyl carbon. So that's going to be present in every one of these molecules. You'll notice we have a double bond oxygen there. So obviously we only have two other single bonds to the carbon because carbon has 4 bonds. So the first one we're going to look at is called an aldehyde. And an aldehyde has a carbon chain on one side, and I'm going to put the carbon in and a hydrogen on the other. Okay. So you can see we've got 1, 2, 3, 4 carbons there. Okay, we've been practicing our lectures from earlier. So we've got 4 carbons attached to the C double bond O. And I do want to point out that you can have it drawn in either direction. There seems to be some inconsistencies within texts and journals, but it can be drawn left to right or right to left. The critical thing is, you look at this carbonyl carbon, we have a hydrogen on one side and a carbon chain on the other. The next example, we move further down the page, is a ketone. Now a ketone looks like this. It simply has a carbonyl center with a carbon chain on both the right and the left. And again, you can see the carbon chains can be the same length or different lengths. And the abbreviation for this is RCOR. I'll put R prime. Now, R indicates an alkyl group. And an alkyl group is simply a carbon chain. So carbon chain, again, from C1 through, let's do C17 for the day. So that's a ketone, that's an aldehyde. We've got carbon chains with hydrogens or carbon chains on either side, aldehyde or ketone. The next one is going to be, trying to keep consistent with my colors here, is a carboxylic acid. Okay, make sure we spell carboxylic, C-A-R-B-O-X-Y-L-I-C, carboxylic acid. This is a carbonyl, as you'd expect, with an OH attached. Recognize this OH is directly attached here to the carbonyl center. So that makes it an acid. Wait, is that the proton of the acid? Is that the hydrogen ion? Yes, it is. That's what makes it an acid. That is what it donates to be called an acid. So that's our carboxylic acid. Please don't consider it as a ketone. It is not a ketone. And an alcohol, because they are both attached to the same carbon center. This is the carbonyl carbon. We have both of them attached. That makes it an acid. It's not two separate functional groups. And acids tend to have an acrid smell. We want to think about acetic acid. Okay, we think about vinegar. This is an example of an acid. Whoo-wee, stinks. And related to that then, based on our experiences of oxygen in water and nitrogen in ammonia, we're going to replace that hydrogen to form what are called esters. And esters are very pleasant smelling compounds in which we have a carbon chain and then a carbon attached to the oxygen. So we now have a carbon, an oxygen, a carbonyl center. This whole thing is an ester. Okay, so we've replaced the hydrogen of the acid with a carbon chain to give us an ester. If I draw it out a little further, okay, it doesn't matter which carbon chain. The carbon chain can be longer attached to the oxygen as opposed to the carbonyl. You see, the carbonyl carbon, oxygen, carbon chain attached. These tend to have pleasant smells. These are the things that plants produce to attract the pollinators. So they're very pleasant smelling. So an ester is going to have the formula CO2R prime, and an acid is going to have the formula RCO2H. That's an acid. So if you see CO2H, it tends to indicate carboxylic acid group. So we have esters. Now, moving on from esters, we're going to have amides. And amides are different to amines in the fact that we are part of a carbonyl center. So we have a carbonyl with a nitrogen, carbonyl with a nitrogen, carbonyl with a nitrogen. These are amides. And then guess what? We can either have two hydrogens or one hydrogen in a chain or two chains. And I know you're already going to give the answers. I can hear you even through the internet. This is a primary amide. This is a secondary amide, and this is a tertiary amide. Okay. Because this is attached to only one carbon, this nitrogen is attached to 2 carbons, and this nitrogen is attached to 3 carbons, which makes it tertiary, secondary, and primary respectively. But again, it is not an amine with a ketone, but encompassing the fact that both the carbonyl and the nitrogen are attached, like so. They're attached to the same carbon center, makes them amides. So we have primary, secondary, and tertiary amides. So don't get these confused with amines. That's important. Moving on a little further, we've got this, which we know is an acid. So if we replace the OH with a Cl or a Br, this becomes an acid chloride. Sorry about that. And this becomes an acid bromide. And you may also refer to this as an acyl bromide or an acyl chloride. But those are your carbonyl centers with the halogens. Not a problem. Okay. And then finally, we have, if we can, I will stop and come back to the last one.